Good evening, guys. Hope you guys are doing well. Okay. Hope you checked out the, the video that I sent, the one for part one, where I was explaining the point and interval estimation. I hope now you can. I hope now you know the difference between the point and also the interval estimation. Hope now you know the difference. Okay. Okay. Just wanna do this. Okay, just gonna put this here. So, okay, now I'm on chapter 10, hypothesis testing one population. Interesting chapter, the easiest chapter, this one. I think this one, it's short, then after I will explain, I will do the question papers. Two questions at least. Okay, now the hypothesis testing, guys, we have the steps that you need to follow under the hypothesis testing. The steps in hypothesis testing. So remember, guys, this is number one. You have the steps that you need to follow. Number one. Number two, you need to check if on the statement that you are given, are they talking about the left-sided, right-sided, and the two-sided? Ne? We have the hypothesis testing under the population mean, and we have a hypothesis testing under population proportion. Note this. That's number two. Number two, and the other one is number three. This one is number three. And also you get the p-values. Let's check. This one is the recap for chapter 9. Okay, let's start with the introduction. The statistical hypothesis, it's when you are talking about the statistical hypothesis is when you're talking about the statement that the statement made about a population parameter. For this one here, that's the definition of statistical hypothesis. Okay, now, okay, we talked about this. I'm just gonna go straight to the questions. Okay, yeah. So in this chapter, we have hypothesis testing for one population and hypothesis testing for two population. The question is, how do you see that when you're given a statement, this one is for one or this one is for two population? How do you see? You will see when you do question, so I can show you guys the difference on how do you see that for when you're given a question that this one is based on the one population and the other one is based on the two population. Interesting. This is the easiest chapter. So we're going to start with the one for the single population proportion, the one for two population, and the other one for two population for the mean, and the other one for population proportion. This is the easiest chapter. Okay, let's start. Where is it? It's very important for you guys to know these 5 steps. Step one is when you formulate the null and alternative hypothesis. Step one. Step one. Always, step one. When you're given a statement, step one, formulate your null and alternative hypothesis. Step two, it's when you specify the significance level on step two and you decide on the appropriate test statistic. It means that after specifying the significance level, you write down the correct test statistic formula that you are going to use on step number 3 for this one. That was step number 2. Step number 3, it's when you calculate the value of the test statistic. Agree on step number 2, you wrote down the formula for the test statistic, the correct formula. Then step number 3, you substitute on step number 3. Then step number 4, you make decision. You state a decision rule and you calculate the p-value on step number 4. And then step number 5, it's when you make statistical conclusions. So it's very important to know these 5 steps, guys. 5 of them. Step number 1, you formulate. 2, specify the significance level. 3, calculate the value of the test statistic. 4, you state a decision rule. Then 5, you make a statistical conclusions. Then let's see. Okay, I think we talked about this one of making uh The alternative. Okay, now for the null hypothesis, ne, we always use equal sign. You say the population is equal to the population of the null hypothesis. We always use this equal sign, ne, for the null hypothesis. Alternative hypothesis, this one, if they say it's left-sided, right-sided, two-sided, it will depend on the statement that you are given, ne? If it's left-sided, it's this one, meaning the population is less than the value that you're going to use. Right-sided, it's greater than. Even the probability, you know that from STTN121, if you are dealing with greater than, you're going to use 1 minus the probability name. Then the two-sided also, the two-sided, you're going to say 2 for the probability part, multiply by the probability that you are given. Then that after calculating the probabilities, you have to say 2 multiplied by that probability. Or 2 open bracket 1 minus the probability. You will see like when we do the questions. Under the alternative. So the alternative, that these symbols, they depend on the question that you will be given or the statement name. Yeah. So specify this, okay. All right. Now this is very important. This is very important. Now remember, if in this case, if n is at least 30, greater or equal to 30, use this formula. If n is greater or equal to 30, use this formula. But if n is less than 30, maybe it's 20, 15, 10, use this one for the t. Now you see the other one is for z, the other one is for t. What's the difference? For the z, you only use it when n is greater or equal to 30, the t when n is less than 30. Okay. Then with this one, we always, the one for the proportions, the n, it's always greater or equal to 30. This one. Yeah, this one. So you need to know these formulas. If n is greater or equal to 30, use this. But if n is less than 30, use t. Then if under the proportions, it's always greater or equal to 30. Okay, then where is it? Um, okay, I think I've explained the 5 steps. We just go straight to the question, even this one. Or if n is greater or equal to 30, use z. But if n is less or less than 30, what you do? Look at this one. I just want to show you something. Example. It says, a manufacturer of a cell phone battery claims that what? The manufacturer of a cell phone claims that the mean lifetime of the battery 30 hours. The mean. You are given a mean, which is 30. Okay. However, an employee claims that the mean is less than 30. You see, the minute you hear, we have another statement. That statement is for what? It's for alternative. Okay. Claims that the mean is less than 30. So under the alternative, you're going to have something like less than 30. Because they're talking about population mean there. So then now look at the random sample. A random sample of 80, 81. You see, 81. Even this one, I think I was supposed to put this, but it's fine. Let me just do this. A random sample of 81. Ne? Now, look at this. Ne? Now, when you look at, they say that a mean, this statement, remember I said it's for what? Alternative here, alternative hypothesis. Then now, okay, renders a sample mean, which is X bar. Also given a sample standard deviation, which is 8. Can you see that the statement, the one where they say that the claims that the mean lifetime is the population mean, this one is the population mean, something like this. The sample mean, you know from STTN121 that it's X bar here. Then already you are given n there, and you're also given the standard deviation. Now it says that test the hypothesis at 5% significance level by using step 1 to 5. You need to know the steps. Step 1, remember, you formulate the null and alternative hypothesis. Let's do step 1. HO, where population mean is equal to 30. Remember, it's this one here, 30, this one. Then HA, I think they wanted to say A here. HA, they wanted to say A, not HO. So HA here, they made a mistake. HA, population mean is less than 30 here. Remember, I said with the alternative statement, alternative hypothesis, they will tell you, they will mention something greater than, less than. If they don't mention less than or greater than or exceed or something, we take it as two-sided. It's two-sided. So it's less than. So this is the one, less than. I'm not sure. I think for this one, you're going to get maybe 1 mark. Step two. Step two, you just do what? You just specify the significance level, which were given here as 5%, 0.05. You just put what? Here, 0.05, just do this. Now, remember you check. Remember what I said. If n is greater or equal to 30, hey, it's obvious, it's greater than or equal to 30 because it's 81. We use which value, which method? Data statistic, the one for z. We just write it here. We say z. I think even this one maybe we can get 1 mark for this one. Step three, you would just write down what you're given here. 30 was the population mean, and 81 x bar is the sample mean. You got it was 28.7. Then the sample standard deviation was 8. You substitute this here. You substitute this, then you get what? The z value as -1.46. Step 4, you need to calculate the probability. Since now it's, remember now it's less than, you're not gonna use 1 minus the probability. See, now we are dealing with the left-sided. So now here, if it's, since it's, you remember when with the STTN121, when you're doing the normal distribution, you know that if it's -1.46, the last digit will be 6. You divide it by 100, 0.06. You're going to check this probability under the negative table, -1.4 under 0.06. Let me check if I still have the tables. Where's the table? Where's the table? This one, there was no table for this one. So, okay. What about this one? -1, comma, where's the negative? We're not given the -1. Okay. Where is it? I don't know if I'll be able to, I'm looking for the formula. Not this one, not this one. -1.46. Wait, I'm looking for this one, yeah. -1.46. The table. Okay, let me just do this quickly. Just wanna do this first. Okay, just wanna download this, the table. Just want to download this table first. And take it was under the documents. Just save it here. Downloads. Then go to the site. Okay, then you do this. Oops. Okay, where's the thing? Right. The document. Shift is this one or this one. So let me just do this. And then open the documents. Okay, this is the one. All right. Okay, here it is. It was -1.46. -1.46. So the last digit 6, you divide it by 100, and then you go this side. And then -1.4. You go this side, you go this side, you go this side, you go this side, you go here. And 0.0721. Where is it? 0.721. Here it is. And you're done. Now, you're going to compare this 0.0721 with the alpha, with the level of significance, which is, it was 0.05. You want to check if Is 0.0721 greater than 0.05? Yes. Here it is. The p-value is greater than alpha. So if the p-value is greater than alpha, the level of significance, you do not reject the null hypothesis, or you fail to reject the null hypothesis. That is step number 4. Step number 5, you make the conclusion. You go check on your statement, or what is the claim there? An employee, remember, they say that a manufacturer of a new cell phone battery claims that the mean lifetime of the battery 30 hours. However, an employee claims that the mean is less than 30. That claims that the mean lifetime of the battery 30 hours. Since we do not reject the null hypothesis, it means that the manufacturer of that new cell phone battery is correct, because we do not reject the null hypothesis. We do not reject the null hypothesis. I'm not sure about the mark allocation for this. So I hope now you understood. Okay, let's go to the second example. I want the one where the n is less than 30. Because even this one is still the same thing. I've showed you how to do this to this one. Now this one, remember the reason why it's greater than here, because the same thing is that one. The only difference, I think, the alternative and the null hypothesis. Remember, if the statement they mention something like, you see, it was greater than, higher than. So it means the z value is going to be greater than. If it's 2.67, remember 1 minus the probability there on the table, and then 1 minus, you will get this answer here. And obviously 0.0038 is going to be less than the alpha. Therefore, you reject, meaning if p-value is less than alpha, you reject the null hypothesis at the level of significance. I just want the one where it was less than, because now here it's the same formula. You see z, even this was the same formula. Okay, let's look at this one. The standard deviation, even this one, let's see if it's the same thing. This one is two-sided. You know why? Because when you look at this statement, there's no way here, they're not mentioning it's more than, less than, greater than. So yeah, it's like that. So you're gonna use this method, the two-sided. The two-sided, remember, you specify the level of significance. You write the correct z value, z formula. You get the z value. You say 2 multiplied by, since it was 1.06, it's gonna be 2 open bracket 1 minus the probability that corresponds with 1.06 here. What if here the z value was negative 1.06? What if it was negative 1.06? You're just gonna say 2 and then multiply by the probability that corresponds with this. You write it here. No need for 1 minus. We only use 1 minus if this one was positive. But the fact that it's two-sided, you have to put 2. You have to multiply your probability or the whole thing by 2. And then you get the probability. Then you check the condition of, if it is greater than, you do not reject. If it's less than, you reject. Yeah. I'm looking for which one? I'm looking for this one of t when it's less than. Let's look at the example. You see this one? You are given a data set. 1, 2, 3, 4, 5, 6. 6. Or 1. So it means here, they say, suppose a sample of size 6, and it's 6, is available to test if the mean mass, they're talking about the population mean here, of forces in a large head exceeds, which is greater than. This is the statement for alternative hypothesis. 450 will be the one for the population mean. It means here, from this data here, you need to find the x bar, sample mean. You also need to find the sample standard deviation as x here. So you know that under the alternative is equal to 450. Remember I said the null hypothesis, we always use equal sign. Alternative, in this case, it was greater than because the word exceeds. So it was greater than here, greater than. Step 2, you specify the level of significance we were given as 5%. the X bar, you're going to substitute this on the method you guys know. To find those values on the calculator, you find the standard deviation, you find the mean. So here, the substitute here, the reason why it's t is because n is less than 30. Remember? Then they got the t as 2,201. Now, after getting the t, now, you remember there's this video that I did, test one preparation. I explained the method of the t. How do you find the TG, T1? How do you find the P2, P1, T2, T1? I've explained this one on the test one preparation, this method. Now, after you check, the probability was 0,0395. You're going to compare this 0,0395 with the level of significance. So it's obviously the level of significance will be the bigger one. So therefore, you reject the hypothesis. Then after, make a conclusion. Yeah. If you reject, remember they said the mean mass of horses in a large herd exceeds 450. They want to test if the mean mass of horses in a large herd exceeds 450. So if we said we reject, it means that at 5% level of significance, it is decided that the population mean exceeds 450. Mean that statement will be the one for the alternative. They're accepting the alternative hypothesis statement. Then what's the other one? Even here, n is less than 30. You need to check if it's greater or equal to. I mean, if it's greater than, less than, or two-sided. If you check here, okay, does the sample mean contain sufficient information? Are they talking about greater than, less than? No. So it means that this one is going to be two-sided. Can you see? Two-sided. You get the T after you use this method here, because I think I've explained it there on test one preparation. You get the T there on this one. Then you get the probability, you compare it with the level of significance. Therefore, you reject the hypothesis. Then after, you get the conclusion. So that's how you do it. Then the one for the P cap, the sample proportions. Interesting because it always, this one deals with the large N. This one, you won't use a formula where N is less than. With the proportions, always greater than N, greater or equal to. So even this one, HA, left-sided is going to be less than, right-sided greater than, two-sided, something like this. You need to check on your statement if they're talking about greater than, less than, or if they're not talking about greater than, less than, or exceeds, it's going to be two-sided. So yeah, let's look at the question. A manufacturer claims that 5%, this 5%, what is this 5%? There, something like this. This population proportion, the percentage produced are defective. Out of 200 randomly chosen items from the sample store, 14 items were defective, meaning 14, it's X, and 200, it's N. Now you can get the P cap by saying the P cap is equal to X over N. You see? Yeah. Is there sufficient evidence to show that more than, greater than? So under HA, population proportion will be greater than 0,05. Let's check. You see? Null hypothesis, we always use equal sign. Alternative, I think they wanted to say HA. Alternative, it's greater than because of this more than, like this. Step number 2, you specify because already we're given the alpha is 0,1. Here, 0,1. The formula we're going to use the one for the P cap, the C. Guys, remember, with this kind of questions, you need to check. If you're given a statement, check if you are dealing with the mean, a given mean or given standard deviation, if n is less than 30 or n greater or equal to 30. If they give you the percentage, they give you the x, they give you the n, now you're dealing with the proportions. You write down the formula, the 0,07, it comes from where? From the P cap, remember, it's 14 divided by 200. And I think 14 divided by 200, you'll get 14 divided by 200. You get 0,07, yes. It comes from that. Because the x is 14, the n is 200. And then you substitute, you get the probability. I mean, you get the Z value. They got 1,298. You go to remember, you need to run this to two decimal place. Since it's greater than, you're gonna say 1 minus the probability, and then you'll get the final answer is this one. You're going to compare this 0,0968 with the level of significance, which is was 0,1. The bigger one is the level of significance. Therefore, you reject the hypothesis. Then after you do what? The conclusion. So that's how you do it. Even this one here, the percentage here will be what? Will be the pi. This one, the pi, will be the pi. And then you're going to check a random sample of 500 clients. So n is equal to 500. Then show that only 275, which is x. Now, you see on this one, they're not talking about greater than, less than, exceeds. It's two-sided. Under the HA on that one. That one was two-sided. So I think, yeah, I think the only thing that you see is tables here. So I think that the end of the chapter 10, because I don't see the the two population. Maybe it's not part of this chapter, the two population. Okay, let's check this question paper. Unfortunately, the only question paper that I can get, it's the question papers plus the memo. Those are the only question paper that I can get. Let's look at this one. They say a supermarket manager suspects that the machine filling 500-gram containers of coffee are overfilling them. A random sample of 50 of this container is selected from the shelves, and the sample mean it's 501.8 grams with a sample standard deviation of 60. What are the null and alternative hypotheses to be tested to determine whether the manager's suspicion is justified? A supermarket manager suspects that the machine filling 500 containers of coffee are overfilling them. The sample mean, remember, is X bar. This 500 will be population mean. So let's check. Containers of coffee are overfilling. Overfilling them. A random sample of this content is selected from the shelf, and the sample is found to be this with this. So it means that the statement that you're going to take the one with 500 as the population mean, and then the alternative as the population mean greater than 500 are overfilling them. A random sample of 50. Yeah, with this one. Now they want you to use the test statistic. Which formula are you going to use? Check if n is less than 30. Is n less than 30? No. It's greater than 30. So which formula are you going to use? You're just going to say now, we're going to use the one for z. Z is equal to what? What is x in this case? What is x bar? The x bar. It's 501.8. So you're just going to do something like this. 501.8 minus, what is the population mean? 500. And then do division. Divide by what? What is the sample standard deviation? Which it was 60. Yeah, it was 60. 60 divide by the square root of what? Divide by square root of n. And what is n in this case? It was 50. Was it greater than 30? It was 50. And then substitute this on the calculator. So it's gonna be 501.8 minus 500 divided by 60 over square root of 50. And you will get 0,21. Correct. Check if n is less than 30 or greater than. If it's greater than 30, use this method, this one of the z. You're not going to use the one for t. Question 3. Suppose the significance level of the hypothesis test is 0,055% and the p-value is 0,4. Before you even read the question, you need to check. Between 0,05 and 0,4, which one is the larger one? Is the p-value. Therefore, the p-value is greater than alpha. So therefore, what do? We do not reject, or we fail to reject the null hypothesis at 5% level of significance. If you check here, Or is this the same question on the that statement? Remember, it says that the manager now suspects that the machine filling 500-gram containers of coffee are overfilling them. But since we said we do not reject, it means since we said we do not reject HO, it means that there is insufficient evidence for us to conclude which the machine filling 500-gram containers of coffee is overfilling them because we failed to reject the null hypothesis because we do not reject the null hypothesis. So yeah, you're going to remember the reason why I said do not reject is because you're going to compare the p-value with the alpha. And the p-value in this case is greater than alpha. So therefore we do not reject or we fail to reject the null hypothesis. Yeah. Now we're given another statement. They say a researcher makes the following statement. The average number of days that the students are absent during their first year of study is 15. Okay. Another researcher claims that the average is more than 15. They said more than. Remember, they said more than. 1 minus the probability. They decide to draw a sample of 50 students and it's greater or equal to 30. They ask each other of them how many days they were absent in their first year of study. The value of the test statistic was calculated to be 1,62. Already we are given the value of the test statistic 1,62. We want the probability. So 1 minus, because of they said more than, minus the probability. The test statistic is 1,62. Last digit is 2. We divide it by 100, 0,02. We go to uh, the table. We are going to check 1,6 under 0,02. Where's 1,6 here? And then it's going to give us 0,9474. 9474. 0,9, 0,9474. And when you say 1 minus 0,9474, you will get 0,0526, which is this one here. This one. You will get that one there. So yeah. So you see, it's very important for you to check if you're dealing with less than, minus, or greater than here. That was question 4. Question 5. Consider the following pair of hypotheses where population proportion 1 is equal to population proportion 2. I think here it's two populations, and you guys, you said it's chapter 9 and 10. And both of those two chapters, there's no two populations there. I checked. On chapter 10, there's no two populations, there's only one population. I checked there, it was only one population. So this one won't be part of the thing test. Now look at this one here. This question, it's 6 marks. You just testing using those 5 steps. Look at the question. STTN121 students are currently not given hard copies of the notes. Lecturers would like to provide hard copies of the notes, but will only do so if at least 75 of the students indicate that they prefer a hard copy to an electronic copy. A random sample of 50, n is equal to 50, is of STTN121 student is selected, and 33 of them say they will prefer hard copies of the notes. A hypothesis test is performed to help the lecturers to decide if hard copies of the notes should be given to students. Already you can see you're not given mean here. So this is X, and this is N, and this is the population proportion, the percentage. The population proportion, the percentage. So, or no, what you see when looking at this question, you don't see a question where they say that if at least 75 greater than, at least 75 greater than, and when it's greater than, 1 minus the probability. So we're going to use the method of the population proportions. You say population proportion, HO population proportion is equal to 0,75. It comes from here. Alternative, population proportion is greater than 0,75 because of this greater than. You see, greater or equal to 75%. You get 2 marks, you see? Then step number 2, that was 6.1. 6.2, you calculate the test statistic. You know the formula that you are going to choose. The P cap, remember, it has its own formula, X divided by N, which is, it's going to be 33 divide by 50, and then you will get, you see 33 divided by 50, you get 0.66. You substitute your information, you get negative 1.47. Guys, don't forget to round off your final answer to two decimal place. It was negative 1.469, then you're gonna get negative 1.747. That was step number 6.2. 6.3. Suppose you do not reject HO, what conclusion will you make against 5% significance level? Check here. Now, remember, they said there is insufficient evidence because remember they said you do not reject. So it's going to be insufficient evidence to say that the population proportion of those students who prefer a hard copy to an electronic is more than 75. Why are we saying insufficient evidence? Because we failed to reject the null hypothesis at 5%. Was it 5%? Or is it? Uh, yes, at 5% level of significance. Yeah. Then you get full marks, six free marks. You see? And then question 9. This one is 9 marks. Let's check the question. A perfume company is, guys, make sure that anytime you're given a question, make sure that you read the question and also you understand the question. You write down, okay, this one I'm giving the population, this one I'm giving this one. Okay, this one, I think it's population one and it's two populations, this one. But let's check. A perfume company is planning to market a new range in order, or fragrance, yeah, fragrance in order to test the popularity of the fragrance. 140 is for young women, 130 for older. Were selected at random and asked whether they liked the new fragrance. I think this is two populations. Just trying to check something. Yes, this is okay. The sample size 1, sample size for the young, and sample size for the old. The number of people who liked, and also this one. It's two populations. This one. This one. Where is it? Yeah, it's two. I see two populations. Because when I checked here, the scope that you guys gave me, there's no two population here. Because you said it's based on standard 9 and 10. There's no two population here. You see? It's only one population. Even the question that we given to us, only one population. There's no two population. So unfortunately, I won't be doing this one. Because you said it's not going to be there. Even this one is also two populations. So I'm not going to do this one also. So yeah, hope you can also see. Hope you understood. What's the other one? This one here. Where is it? Where is it? Where is it? The confidence. Confidence. Okay, the average, question 2. The average weight of all residents in Sharpeville is 168, the population mean, with the population standard deviation, meaning the population standard deviation is known. Okay, a nutritionist believes the true mean to be different. She measured the weight of 36 and is greater than 30 and found the mean to be 169.5. State the null and alternative hypothesis. Obviously, you can see that they didn't mention greater than, less than, so it's two-sided. So population mean is equal to 168. Then this one is going to be two-sided. Okay, at 95% confidence level, is there enough evidence to discard the null hypothesis? Because now when you look at this, it says that the average weight of all residents in Sharpeville is 168 with a population standard deviation of 3.9. A nutritionist believes the true mean to be different. So it means that here you need to find the level of significance by saying what? 1 minus 0.95. You're going to get 0.05. That will be your alpha. Already you have your information here. You substitute, get the test statistic as 2.31. Since it's two-sided and the z is positive, it's going to be 2 into 1 minus the probability that correspond with, let me show what I'm talking about. 2 into 1 minus, it's 2.31. So the last digit is 1. So you want to check under 2.3 under 0.01. 2.3 under 0,01. This is 2,3, 0,01. So it's 0,9896, 0,989896, 0,98, 0,98, 0,9896. And then you punch this on calculator. So you're gonna get what? 2 into 1 minus 0,9896. And then you'll get 0, check something here. Okay, 2. Okay, this is, we see, where is it? 0,9896, our probability. So, just gonna check something. 0,9896, which is, yes, yes, yes. So here, it was supposed to be 0,02, 0,0208. If you punch this on the calculator, if we say 2 minus 1,9792, you will get 0,0208. So they made a mistake here. It was supposed to be 0,0208. So it's either you can do it this way. You'll be like, oh, since the positive, the z is positive, and I'm dealing with the two-sided, it's gonna be 2 into z is positive, 1 minus the probability, close the bracket, you get the answer. If the z value was negative, you're gonna say 2 into the probability on the table. You don't have to say 1 minus. So yeah. So now since the p-value is 0,0208, and that 0,0208 is less than 0,05, therefore what we do? We reject the null hypothesis. Therefore, you can conclude that the means are not equal, because they say that the two means to be different. Yeah. Then what's the other one? Okay, this one. Check if n is greater or equal to 30. This one, n is less than 30, you see? Then you'll be like, oh, and I'm given a data set. So it means you're dealing with the sample mean and the sample standard deviation. So therefore, you introduce t. Here it is. If you want to know how to use calculate the probability when you're dealing with the t, go and check test 1 preparation. I think part 2. Test 1 preparation part 2. So yeah, I think the rest of the question is two populations, and the scope that you guys gave me doesn't include the two populations. Yeah. So I hope you understood. And remember, practice and make sure that you understand the basics. Yeah, so that will be the end of the recordings. Please don't forget to like, subscribe to my YouTube channel so that you can see more videos of STTN121. Remember, statistics is enjoyable and engaging. Go.